Hello. Today's video, I'm going to be trying to prove this cosine of 1 over n is a Cauchy sequence. These are from the Real Analysis course by the Math Sorcerer. I definitely recommend checking it out and follow along with me because I'm following that course and documenting it at rakugakistudy.com. So if you need any help with any solutions and I figured out how to do it or explanations, it's probably going to be on that website. Okay, so I've watched 27 and how he proved the Cauchy sequence there. So this is going to be more of a live stream type video where I struggle to do a proof in front of you. So let's get into it. Okay. So to prove it's a Cauchy sequence, we need a, n, and m. Sorry, the difference between a, n, and m to be less than some epsilon margin, right? And that's for all n and m greater than some number n. So after a certain point, they're all going to be less than epsilon. And that's a Cauchy sequence. So how do we do that? Well, let's think about this. Well, let's write this out fully. Cosine the cosine of 1 over n minus cosine of 1 over m needs to be less than epsilon. Okay, and I assume we can separate it into a cosine of 1 over n plus a negative cosine of 1 over m, and that's going to be less than epsilon. Actually, I'm gonna stop writing less than epsilons for this problem because that's just gonna get very confusing. So we know that this is going to be greater than or equal to this up here because of the triangle inequality. And there was a property that I remember from a previous video. It's like sine of 1 over n, the absolute value of that is less than 1 over n. Some property like that. Okay, so I think I may have got it. Let's try this. So you've got a cosine of 1 over n. Take the absolute value of that. That can, at max, be equal to 1. And 1 over n is also at max equal to 1. So they're either equal to each other something 1 over n. cosine of 1 over n down. So what does the cosine of x do when compared to x? It means cosine is always less than or equal to x as well, because cosine is just sine shifted by, what is it, pi on 2. Okay. I think that could work. Hold on, it's the absolute value of x. Yeah, so whatever holds for sine should also hold for cosine of x. So we're going to use this fact. Okay, that means cosine of 1 over n is less than or equal to absolute value of 1 over n, and also less than or equal to absolute value. So cosine of 1 over m is going to be less than or equal to absolute value of 1 over m. Also, we can get rid of this negative sign because you're taking the absolute value anyways. You can get rid of the absolute values because these are both positive. Integers, actually. Yeah. And then we're going to want this to be less than epsilon. Well, I'm thinking we can do both of them at the same time. So if we want 1 over m n less than epsilon, then we're going to have an n that's greater than 1 over epsilon, and that should work. Okay, so when we do the proof, how does this work? Okay. For all, no. So you want an epsilon greater than 0, and okay, so this was how you write the convergence of a sequence proofs, not called Cauchy sequences. So Cauchy sequences, we're gonna go let epsilon be greater than 0, and then we can choose an n greater than 1 over epsilon such that for all n and m greater than n, something happens. Well, that's going to be our cosine of 1 over n minus 1 over m, absolute valued, is going to be less than or equal to the cosine of, I'm just copying down what we wrote before. Find we found that n is greater than 1 over epsilon, and then tangent, I'm going to go in a, this is separate to the proof. N is greater than n, which means that n is greater than 1 over epsilon, and solving for means epsilon is less than 1 over, oh, no, epsilon is greater than 1 over n. I was getting scared there. Okay, so do the same thing for m. We get epsilon is greater than 1 over m. I'm also not going to call this a tangent because that's kind of confusing. I'm going to say since n is greater than n, that implies that n is greater than 1 over epsilon, and then we get epsilon is greater than 1 over n, and epsilon is greater than 1 over m. So if we continue our proof, that must be less than epsilon, because 1 over n is less than epsilon, plus epsilon. Well, technically this proves it because epsilon is any real number greater than 0, but we can make it nicer and up here change that to epsilon over 2, and then we get 2 on epsilon. So you multiply by, what are we solving for? N, right? Yeah, you get 2 on epsilon, which means if we go n is greater than 2 on epsilon, and we solve all the way down here, and n is greater than 2 on epsilon, m is also greater than 2 on epsilon, 2 on, nope, epsilon on 2 is greater than 1 on n and 1 on m, which gives us epsilon 2 and epsilon 2, which is less than epsilon. And that's the proof. So, yep. Also, this fact here, you can go back to the video, let me check which one it is. You can go all the way back to lecture 20 in the course. You can go back to lecture 20 and yeah, you'll see the sine of x version of that. We just use that here. So that's my proof. I got a glimpse of what the math sorcerer did, and it looks different. And I'm pretty sure he didn't use this cosine of x thing. So yeah, that's going to be interesting looking at that. Anyways, there's the entire proof if you want to look over it. And I'll see you in the next video that I do. See ya.